Steam enters a turbine at 30 bar and 300 degrees Celsius where U is equal to 2750 kilojoule per kilogram and H is equal to 2993 kilojoule per kilogram, and exits the turbine as saturated liquid at 15 kilopascal where the internal energy is 225 kilojoule per kilogram and the enthalpy is 226 kilojoule per kilogram. The heat loss to the surrounding is 50 kilojoule per kilogram of the steam flowing through the turbine. Neglecting changes in kinetic energy and potential energy, the work output of the turbine is, so we need to find the work output here. So from steady flow, steady state energy equation from the first law of thermodynamics, we know that if we write this equation per unit mass, so we can write H1 plus V1 square by 2 plus GZ1, the potential energy, plus dq by dm is equal to heat transfer per unit mass H2 plus V2 square by 2 plus GZ2 plus work done per unit mass. Now in the problem it's given that we have to consider that the kinetic energy is 0 and the potential energy is 0. So we need to neglect these two. Okay. Also 1 represent the inlet condition and 2 represent the exit condition. So from here we can write H1 plus dq by dm is equal to H2 plus dw by dm. Now according to the problem, H1 is 2993 plus dq by dm is minus 50. Heat is lost to the surroundings, so it will be negative, and this will be equal to H2, which is 226 plus dw by dm. So the work output from here per unit mass, so dw by dm will be equal to 2717 kilojoule per kilogram. Okay, so this is the specific work output. So let's fill in the blank. So the work output of the turbine is 2717 kilojoule per kilogram. For more on steady state, steady flow energy equation, you can refer to the NPTEL course, lecture number 22. First law for steady state, steady flow process on the concept of thermodynamics by Professor S. Chakraborty of the Department of Mechanical Engineering at IIT Kharagpur.